Why do we lose energy as we grow older? Why are some of us prone to disease? Why do our bodies deteriorate with age? The answers to some of the most intriguing questions about life may be found in parts of our body 1 billion times smaller than a grain of sand.
Mitochondria are critical for health. The more mitochondria you have, the lower your risk for developing many chronic diseases.
Firing up your mitochondria can transform your health and fitness, and the evidence is mounting you can do it incredibly fast.
When I started, there's no way I would have thought that such a low volume of exercise, just a few minutes per week, could have had such great benefits.
There's no question that exercise alters the course of aging. We assume that the improvement in mitochondrial function is orchestrating many of the benefits.
The more rapid and intense you do, it seems the better outcome.
It sounds too good to be true. But in this episode, I try to go from average to fit with just 6 minutes of exercise.
To many of our body's proteins, enzymes and DNA, oxygen is actually a destructive molecule. So why then do we crave it so badly? As it fills our lungs and circulates through our blood, oxygen has a very specific destination, the tiny powerhouses of our cells called mitochondria.
So the average individual may have literally billions of mitochondria in their skeletal muscles, and the trained individual even more. And it probably comprises 10% of an individual's body mass, so it's a fair old proportion.
Mitochondria use the corrosive power of oxygen to strip electrons from the food we eat to create energy in the form of a molecule called ATP. Extraordinary energy.
So from a purely evolutionary perspective, you know, mitochondria are the reason we're here, the reason that we have evolved into the human species that we are, indeed animal and mammal species.
From the tiniest seedling to the biggest blue whale, mitochondria power growth, flight, thought, movement, and the diversity of multicellular life. How much oxygen our mitochondria can consume when we push ourselves to the limit is the gold standard measurement of aerobic fitness. It's called VO2 max, and I'm here at the Victoria University Institute of Sports Science to have mine tested. It's the baseline measurement for the start of my 15-week exercise journey.
It's a good measure of the metabolic health of your muscles. So we know, for example, with endurance athletes, that they'll have a very high VO2 max, and people who sit on the couch, they'll have a very low VO2 max.
As a person who's been embarrassingly slack these past 2 years, I'm expecting to fall somewhere in the second group.
Yeah. The slower you go, the higher the resistance to maintain the power.
So keep going fast.
If you can try keep your RPM, you'll find that kind of at the end, you'll start to slow down.
The end goal of this unpleasant test is to run me into the ground.
Now, so we're just pedaling like that for a minute and then the workload will go up.
We'll start off with someone exercising easily, and they'll need to use a little bit of oxygen to produce the energy, and then gradually we'll make them work harder and harder, and each time they'll need to use more oxygen to produce more energy so they can do the extra work.
Another minute, let's go, keep working.
Eventually we'll come to a point where your body can't use any more oxygen, and that's what we call the VO2 max, or your maximum oxygen capacity.
Excellent work, keep it going.
VO2 max is an indicator of more than just fitness. The lower my result, the higher my risk of all sorts of illnesses, including cardiovascular disease, diabetes, and even cancer.
Keep going, keep going, keep going. Okay, stop pressing.
Great job.
Good job.
Awesome. Great work.
That was hard.
Excellent.
Was it?
Right, it looks like you gave everything you could there, so you didn't leave anything on the bike. So the VO2 max, we'll have to do the calculations, but just quickly looking at it, looks just above 35
Okay.
mils per kilogram. So
how does that compare to everybody else?
It's definitely good, and it's probably average or even slightly above average, so I think you might have underestimated your endurance fitness.
Or my ability to try hard.
Yeah, to push yourself at the end there.
After the numbers are crunched, my final VO2 max reading is 36. To give you a comparison, top female athletes register scores in the 60s and 70s. I've also taken a DEXA body composition scan to see if my fat and muscle mass change in the weeks of exercise ahead.
Definitely, I'd expect that to have a pretty big improvement in the next 16 weeks. And we'll see that when you come back to do this all again.
Great. I look forward to doing it again.
The current recommendation for the average person like me to increase their health and fitness is to do moderate intensity exercise and lots of it.
The current health recommendations in Australia and most other nations are for approximately 150 minutes a week of aerobic-based exercise, which is an awful lot.
Quite a lot. I never seem to have the time.
Well, funny you say that, because the number one reason that most people give for not exercising is actually a complete lack of time, and as a result, people don't exercise, and that really equates to the current health epidemic that we've got for obesity, type 2 diabetes, and a lot of what I would call inactivity-related metabolic syndrome.
But the notion of how much time we need for exercise has begun to shift. It all began with a series of studies led by John's former collaborator, Canadian Professor Martin Gibala. He found that as long as the intensity was high enough, you could make big improvements in a fraction of the time.
Good work, good work, good work. All the way through, all the way through. Our initial study, we used something called a Wingate test, and what that is 30 seconds of all-out exercise on a bicycle. Great job. It's hard to convey the intensity that's required, but I'll use the phrase, sprinting away from danger pace. It's about as hard an effort as you can give, but the test only lasts 30 seconds. And we had subjects repeat that 4, 5, or 6 times with a couple of minutes of recovery in between. And so the amount of exercise in a training session was only 2 or 3 minutes.
In just 6 sessions of low-volume, high-intensity interval training, or HIT, Martin's sprint group improved their endurance dramatically.
The results were quite striking. We saw a doubling of their endurance capacity. So if they could ride a bike for 25 minutes beforehand, after those 6 sessions, they could ride a bike on average for 50 minutes. Good work, all the way through, all the way through. Nice job. So that's quite a striking improvement in their endurance capacity. And it's something that we might see with many weeks of more traditional endurance training.
It sounds crazy to me, but also intriguing. Could I possibly improve my fitness with just a few minutes of exercise a week?
Done my warm-up.
Okay, Anya, you ready to go? Good.
Yes.
Bottom of the hill for you, first repetition.
Right.
I'm adapting the Wingate test used by Martin's group, but I'm taking it outside.
Go!
For 4 months, my program is 4 30-second sprints 3 times a week. If you think a flat-out 30-second sprint is easy, think again. It takes me 2 weeks just to complete a full session without straining my muscles.
I don't think I did something very good to my car.
Starting on a hill is a stupid idea. A bike is much, much safer, but still not easy.
My health psychology colleagues are constantly reminding me that interval training hurts. It's an uncomfortable way to train, but I do think there's merit in the approach.
A rest between each sprint for 4.5 minutes brings my heart rate back down and prepares my body to go flat out again. So the session takes 20 minutes, even though the total sprint time is around 2 minutes. Although I can't say I find it exactly fun, it's over in a flash. And since Martin Gibala's early work, there's lots more research to support the idea that a little bit of high-intensity pain offers a lot of gain.
The amazing thing is, if you look at some of the physiological adaptations, they're similar, or in some cases better than the traditional model.
Good job.
HIT is a very potent intervention for improving insulin sensitivity, and insulin sensitivity is very important because it's been linked to, obesity and type 2 diabetes.
Subjects after a few weeks of training have slightly lower body fat and slightly higher lean mass, and so we know that's associated with improved health outcomes. And we've also seen reductions in blood pressure as well. And we'll see that even within a couple of weeks, we can get an improvement in your VO2 max of 10 to 15%.
The improvement in VO2 max is largely to do with how your mitochondria adapt, and this is the change I find most exciting. While Martin's team have measured a rapid increase in the number of mitochondria following sprints, David Bishop has just discovered they make a huge improvement in function.
We take a very small muscle sample from our participant's thigh and we give it all the food it needs, and we look at how well it can use oxygen to produce energy. So basically we measure the ability of that piece of muscle to use oxygen.
In his flat-out sprint group, mitochondrial function improved by up to 30% in just 4 weeks. In the endurance group, he observed no significant change during that time.
Pretty much all 3 types of exercise had a pretty similar improvement in VO2 max. It was only when we dug down at the muscle level that we could see actual differences.
Great job, keep on pushing.
So what's the secret? How can such a small amount of exercise get such big changes?
Good job.
High-intensity exercise places enormous pressure on your system to produce high amounts of energy fast.
Your mitochondria respond by being better able to take that oxygen out of the blood into the muscles and using that to produce energy.
It's happening in literally billions of mitochondria throughout your body, in fast-twitch, intermediate and slow-twitch muscle fibres.
When you do low-intensity exercise, even though it might feel like it, you're not actually using all of your muscle. You're only using the amount of muscle that you need to do that particular type of exercise. Whereas when we do very high-intensity exercise, especially sprinting, then you need to recruit all of your muscle fibres at once. What we think is that with the high-intensity training, I think we're probably replacing some of the older mitochondria with new, better functioning mitochondria, and we think that may not be happening as much with the low intensity exercise.
Welcome today, guys. How are you?
Swapping old, faulty mitochondria for better functioning new ones is a reward not to be underestimated.
Well, they're critically important to health. We know that, first of all, if there's mutations in the genes that make mitochondria, this can lead to very serious diseases, often affecting the nervous system, which is why they would come to my clinic with strokes or seizures or muscle weakness, for example. Okay, I'm just going to take a look at your arm here.
Professor Mark Tarnopolsky is currently treating 2 brothers with the same mitochondrial disease.
That's good. Excellent. The first boy, who was our first patient, came to us with a significant movement disorder, and he had a lot of neurological symptoms. The family had a younger son who had started to show just the subtlest of changes in his eye, and sure enough, he had the exact same mitochondrial DNA disorder.
Quick, and touch it.
Mark immediately prescribed a mitochondrial supplementation program with exercise, and so far, the younger boy hasn't developed the same devastating symptoms.
All the way up, tall like a soldier. Good work. Can I get a high five?
But you don't have to be born with a genetic disorder to feel the ill effects of mitochondrial dysfunction.
More recently, we've discovered that there can be acquired mitochondrial dysfunction that can occur in the presence of more common diseases such as Alzheimer's, obesity, type 2 diabetes, and in fact, human aging has even been linked to mitochondrial dysfunction.
In fact, in all of us, mitochondrial function gradually declines as time wears on.
Although they're very efficient at repairing themselves, eventually we can't keep up and the cells start to drop off in energy. When they drop off in energy, they lose their resilience and the cells end up dying, and we can't replace our cells.
As more and more cells are lost, our muscles shrink, our skin sags, brain volume drops, and soon enough we look and feel old. world. Somewhat like these mice. Genetically engineered to have a faulty mitochondrial DNA repair system, these mice age prematurely.
As a consequence, there was graying of fur, cataracts, decreased hearing, smaller brains, bigger hearts, anemia, thin muscles.
They only live around half their normal lifespan. No drugs can halt the disease, but Mark's team have shown that exercise can.
So what we did is we ran them on a treadmill from the time they were about the human equivalent of age 20 to about the human equivalent of age 50, 3 times per week for 45 minutes at a fairly brisk run on the treadmill. And what we found is that we completely protected these animals from all of these pathological premature aging features which I described.
Instead of looking wasted and grey, the exercising mice remained youthful, strong, and didn't die young.
The body selects against the bad mitochondria, and it's almost like putting them through a biological filter when we exercise.
The question is, can exercise protect us humans from natural aging?
Once you're over 40, you'll start to notice a change in the skin you see and feel, the stratum corneum, the final protective layer of your skin's epidermis. It's mostly dead skin and it starts to thicken with age.
At the same time, the layer underneath that makes your skin look plump and moist thins. It loses cells and elasticity even without sun exposure.
So essentially that gives you the sloppy skin with wrinkles and sort of dryness to your skin. And when we take a look at human skin in old people versus young, we see a very significant drop in mitochondrial capacity in the older person's skin versus a younger individual. Fortunately, however, exercise can partially reverse that. We took sedentary people over the age of 65. We did a skin biopsy from the outer butt cheek to avoid the sun before and after 3 months of endurance training.
Biopsies of the active elderly participants improved to the point where they were indistinguishable from younger skin under the microscope.
It looked like a 20 to 30 year youthening, if you will, of the skin after just 3 months of endurance training.
That doesn't mean their wrinkles disappeared, but the dead skin layer thinned while the dermis, full of collagen fibres, thickened.
We had people as old as 86 in that study, and still, I think the point is, yes, it's better to start exercise when you're young and do it throughout your life, but it's never too old to start.
Mark's team pinned the changes down to a protein released by muscles during exercise, which enhances mitochondrial function in the skin. Although his studies looked at endurance, we now know sprints can boost mitochondrial function in a very rapid way. In this unassuming brick semi at the University of New South Wales, Dr. Steve Boucher is using sprints to tackle one of the most dramatic effects of ageing, menopause.
The decline in estrogen, which will be a 90% or no estrogen at all, is accompanied by a whole array of heart and vascular and metabolic effects. For example, the insulin resistance, the inability to get sugar out of the blood will be affected. But the list goes on. So there's hot flushes, inability to sleep, etc., etc.
During menopause, the loss of estrogen also helps pile on visceral fat, the dangerous fat around your internal organs.
Their belt size changes, their tummy goes out, women can't understand why. So why is the visceral fat bad? Well, it drains into the liver, and it's far more blood supply and some nasty chemicals in there called cytokines that makes the liver inflamed. And we think that's one of the major drivers of type 2 diabetes. So we think if we can reduce the visceral fat, which we know is much easier to reduce than the fat on the outside of your body, this subcutaneous fat, then we should see an array of positive health effects.
All right. You're at my house now.
Instead of flat-out sprinting, Steve's developed his own sprint protocol he believes is easier and safer, but just as effective.
Here we go.
The women pedal fast against light resistance in intermittent bursts lasting only 8 seconds, with 12 seconds of light exercise in between. But over the course of 20 minutes, the women have actually sprinted for a total of 8 minutes.
It's not hard exercise, it's fast exercise. So sprinting fast, moving the legs quickly seems to be one of the key ingredients to the success of interval sprinting.
When it comes to fat burning, moving fast is your best friend. It switches on your flight or fight mode, and a flood of powerful hormones like adrenaline and noradrenaline help your muscles, vessels, heart and lungs go into overdrive. The intriguing thing is, the receptors for these hormones are also found on fat cells, in particular visceral fat.
And that's why we think we can reduce the visceral fat, the dangerous fat, which we think drives a lot of heart disease and diabetes, in far less time.
Steve's earlier trial on overweight younger men shows it can be done. They lost an average of 17% of their visceral fat using the same version of sprints, a result which drew world attention.
Well done.
So far, the menopause study also looks promising.
We've had some big effects from some women, which we would expect from our other studies within 8 weeks. A decrease in visceral fat, increase in muscle mass. Arterial stiffness is a big risk factor for heart disease. It's when your heart, as you age, you naturally get stiffer. It's definitely consistently coming down the women, which is pretty exciting. All the women get fitter.
More importantly, they also feel better.
Yes, absolutely. Hot flashes are nearly gone, and night sweats, I haven't had any for the last few weeks. Annoyance with certain people stays.
I am sleeping better, and I do feel definitely more energetic.
I feel very, very energetic, and I feel like I'm a new woman.
Final results on the menopause trial won't be until next year. But my own personal trial of one has come to an end. Moment of truth.
Excellent.
This low radiation X-ray will tell me if there's been any change in my body composition. Across the 4 months, I haven't changed my diet, and I'm wearing the same clothes I wore 15 weeks ago. Any registered change will be due to exercise. As far as fat burning goes, the sprints have worked.
You've gone from 26.6% down to 25.1%. So you've had a 1.5% decrease in your body fat percentage.
Okay.
Now, more importantly, over that period of time, you've lost 1.5 kilos of fat tissue. So the fat loss that you've achieved over that period of time has largely come from the trunk and the legs. Okay. That's a lot of fat tissue, particularly on your frame.
1.5 kilos doesn't sound all that much, but over the 15 weeks, I've lost 5 centimetres from my waist. It's a welcome change, but what I really want to know is, have my mitochondria changed into healthy little powerhouses of goodness? It brings me back to the test I've been dreading.
Start turning the pedals when you're ready.
Do a big effort.
Well done. Great job. Keep
Great. Keep it there. Yep. Try and keep the RPM up. Excellent work. Excellent. Excellent. Keep it going. Try and finish off the next 10 seconds. Great effort. Okay, you're almost there. Not much further to go. Keep going. Another 5 seconds or so. Keep going. Okay. Great job.
Great job. Excellent.
Awesome.
Well done.
Great work, Anya. You've definite improvement from last time.
Really?
Yeah, I remember last time you were just at the top of the average.
Yeah.
So it's definitely improvement. We'll have a look through the results now and just see how much of an improvement. But you've definitely got some value out of your 6 minutes per week.
And that's just the preliminary results, isn't it? The preliminary results are crunched into a final score as I nervously
And
wait.
also to reach a high VO2 max. Right, how are you feeling now?
A lot better.
Okay, you ready to talk about your results?
Yes, how did I go?
So you've had more than a 10% improvement in your VO2 max. Last time you had a VO2 max of around about 36, which puts you sort of in the middle upper end of average fitness. And this time you've moved up to 40, which just sneaks you into the good fitness category.
That's fantastic. So I've actually gone to being fit. I'm really amazed that I could get those results in 6 minutes of exercise a week. I mean, it was 4 months, but I'm still amazed that that short amount of exercise could move me into the fit category.
It's nice to see an improvement in this number, but most importantly, there's a lot of research associating VO2 max with health. So what that indicates is that you've also improved your health.
It's amazing how these high-intensity intervals have improved my stamina. 4 months ago, I couldn't even jog 3 kilometres. At the end of this trial, I tried again and made 9 kilometres comfortably.
Some of the improvements that we're seeing, 50, 100% improvements, are things that we wouldn't have thought previously. So, yeah, just appreciating the amazing adaptability of the muscle to an exercise stimulus is very exciting.
There's a perception that high-intensity exercise is a heart attack waiting to happen. But surprisingly, that's not true.
Obviously, you want to get checked by a physician first and be cleared medically to exercise, but many more people than we think can safely perform and benefit from an interval-based approach to fitness. Intervals could improve the fitness of cardiac rehabilitation patients to the same level as the traditional or usual care route in less time.
Mini sprint tracks and shorter high-intensity classes are appearing in major gyms everywhere. But the big question on my mind is, can a few minutes of sprints a week really replace the current recommendations for exercise?
It's not a panacea for everything. It's showing a lot of promise in these early phase trials, but we're nowhere near the grade A evidence to suggest that it stimulates all of the benefits of endurance type training over the long term.
No matter how much time you have, the exercise you enjoy will be the one you stick to. And that's the best exercise for you.
I think exercise is mandatory. It's in our genes. If we don't exercise, even if we have a reasonable diet, there's a price to pay.
For more information on different high-intensity training programs and the studies referred to in this episode, visit the Catalyst website.